After we got awarded the project, got through about the 50% construction document, we started getting into the bracing requirements for their RBS. In this case, the developer insisted on an untopped metal deck, but the bracing requirements were just going to be onerous. And also we had steel joists, which are not as easy to connect intersecting beams like we would need for the beam bracing.
Basically, the AISC seismic provisions require lateral bracing for the RBS system, and because the developer wanted to go with an untopped metal deck and steel joist girders, it made it very, very difficult to meet the bracing requirements required by AISC seismic provisions. Simpson strong tie yield links did not require beam bracing that would otherwise be required in the RBS system. We approached a developer who is also the contractor for this project and let him know what we're up against and that we're considering the Simpson strong tie yield link system. One of the big benefits to that is eliminating field welding and the inspection. When we presented that to the developer, he was very pleased with the idea of going away from the welded system and just moving forward with a bolted connection. Seeing how we had already had the RAM model set up for an RBS system, and then once we decided that the Simpson strong tie yield link was a connection that we wanted to consider for the moment frames, it actually was a pretty straightforward, easy process. Simpson strong tie provides an Excel spreadsheet that allows you to input your forces, your member sizes based on your RAM model, and your output for the design. I was able to input that information into the spreadsheet. It provides a preliminary size for the yield link and generates a rotational stiffness that we then put back into the RAM model, and we're able to run the analysis and then finish off the design and the various checks that are required with the yield link system.
Having the built-in option for yield link within RAM makes it super easy to compare RBS or any other option.
Going with the yield link system, the drift is a little bit higher. We had to slightly adjust our original design for the beam size and the column sizes. So there was some increase in steel.
That's been the knock against moment frames. Are more expensive than brace frames because they're heavier steel. The moment frames are designed not so much the strength of the frame, but how the drift controls how much it will move. So they end up with large members, which end up with large welds. So going with the yield link, where it's a fully bolted connection, it has some potential cost savings. The resiliency, that's becoming a bigger and bigger deal for, depending on the client, if that's something they're really interested in. The yield link is much easier to replace than an RBS. If it needs replaced, that's a major undertaking to cut it out, install a new one, weld it up. You can't do welding in an occupied building, where yield link, go in, undo a few bolts, put in the new one, put it back together. Not uncommon to get a manufacturer to have an RFI or a question come up from a contractor that we send to the manufacturer for help. Simpson strong tie has always been very helpful.
Now that we have a couple projects that we've done using the Simpson strong tie yield link system, I think it's very likely that we would consider that in the future, where we normally would have considered the RBS system, but due to the benefits of the bolted connection, we would strongly consider the yield link.